So this last video is going to be an extremely brief overview of how to solve, or basically what everything goes on, like in our code. So what you're going to, I'm going to explain all the functions, and this is just going to, maybe clarify some things in the PDF. So we first have cool drive, which it is something called a driver function. So it's no inputs and no outputs. It should generate a figure, and it should contain most of your constants, so you're going to define constants in here. And it will also have a for loop, very much like, I think they describe it over here. Yeah, so a for loop for I is, or for CNT, which is a counter, is equal to 1:31. And you can see the rest of that snippet over on, the third page of the PDF, page 3, which should be available on the assignment. But it'll contain that for loop, and that'll be where it actually runs cool. And cool is going to be your main function of any level of difficulty for this lab. So cool, I'll explain what the inputs and outputs are. So the input is going to be A, which is just going to be a number, which is your lower bound. B is a number, which is your upper bound. T is your tolerance, and it's also a number. And L is going to be your, it's also a number, and it is the length of the bar, which the length of the bar is just a variable that we're going to vary in cool drive, and it'll run cool basically for different L's. Okay? So that's what cool does. And the output will be X, right? So the first line of cool is going to look like X is equal to cool of A, B, T, L. Okay? Cool fun, I think might be completely given to you, but I'm not doubly sure. Yes, so they completely give you cool fun. So it is given to you, but please replace return with end. There's literally no reason to ever use return, and it'll just create an error. Sometimes if you use both return and end interchangeably to end your functions, or MATLAB will get confused. Always use end-to-end functions in MATLAB. So yeah, those are basically the entire lab. I'll discuss cool and cool drive a little more, but you are going to do the figure. And one big thing that this for loop does is it'll actually help you store your numbers in the vector. And this figure can be done by doing plot basically your L vector, which is going to be, I always would call it LVec, with your decay rate, which is XVec dot squared. So if you put your results in this for loop into a vector called LVec and XVec, then this would be the plot where the LVec is in the X coordinate, or the L values, the lengths of the bar, and the decay rate is the square, and it is in the Y coordinate. Cool is where bisection actually happens. So bisection happens, and this is where f of x where I discuss an f of x in our first video and second video, is just going to be equal to cofun of x comma L, where L does not depend on x, and x is the x that you get whenever you're talking about f of x. So this should be sort of the entire project explained. The main place where I see students mess up is this for loop, and in getting some values, for the boundary conditions. It's like these boundaries, this function you have looks sort of like this, where they're like ripples, and the density of these ripples sort of depends on the value of L, like the length of them. So try to find this point, the first non-zero time that it crosses the x-axis. So yeah, that should be it for this lab. And you can see an example of the plot in the, I believe it's page 2 of the PDF. So this should be enough to get you started on the lab. I'll be holding office hours next weekend, and go to your RLA's office hours to get anything debugged. Okay guys, bye.